नमस्कार बच्चों। मेरा नाम धन्या और हम लोग सीख रहे हैं ग्रेड 11 केमिस्ट्री का ऑर्गेनिक केमिस्ट्री and we are learning the IUPAC nomenclature. In the previous video, we learned some of the rules for the nomenclature of alkanes. Okay, and in today's video, we will be learning how to name the alkenes and alkynes. Okay, now to start with, what are alkenes and alkynes? Alkenes are the hydrocarbons that have carbon-carbon double bonds between them. For example, if I write an example, CH2 double bond CH3. This is an alkane. This is a hydrocarbon with carbon-carbon double bond. Another example, CH2 double bond CH double bond CH2. This is also an example of a hydrocarbon having carbon-carbon double bond. Yes. And in the previous video, we learned because of the catenation property of carbon, it can form long chains of carbon atom, and it also has the property to form double and triple bond. Yes. So this is an example of alkane where carbon is forming double bonds. Carbon also can form triple bonds. And when they form triple bonds, it is called as alkynes. So this is an example of an alkyne where there is carbon-carbon triple bond. Okay. So we will learn the nomenclature of alkanes and alkynes. Okay. So students, in the previous video, we learned the nomenclature of the alkanes, and we followed the rule where we named the substituent first, substituent, and after naming the substituent, the spelling is wrong. Substituent first, and then we name the word root, how many carbon atoms are there. Okay. And then we did the primary suffix. Primary suffix means if how many bonds are there between the carbon-carbon atoms. Okay. And we did not learn anything about the functional group. We will be doing it in a separate video. Okay. Now, let's check out the rules. The general rules are the same that we followed for the alkanes, but there are some rules that we follow during the nomenclature of alkenes and alkynes. Now, so this is our objective for today's lesson, nomenclature of alkenes and alkynes. Okay. So first rule is always the same that we did for alkenes, that is, select the longest carbon-carbon chain. Okay, this is the rule that matches with the nomenclature of alkenes. But here, you have to select the longest chain having maximum number of double or triple bond. So how many double bonds and triple bond, as much as you can include, you select that chain. Okay. This is one of the rules. We will do examples for everything, don't worry. Second rule is that the numbering is done in such a way that double and triple bond gets the lowest number. Okay. So numbering is done such that double and triple bond gets the lowest number or lowest locant. Lowest number. Okay. So first you select the longest chain that includes as many double and triple bond as possible if there are multiple double and triple bond in the compound. And numbering is done in such a way that double and triple bonds get the lowest number. And if we compare the substituent, you know the substituent, right? Substituents like nitro group, halogens, chloride, bromide, iodide, methyl group, ethyl group. All these are substituents. Okay, these are written first, right? So these are the substituents we mentioned here. First the substituents are written, then the word root, then the suffix. Yes. Now, if there is a priority between substituent and double and triple bond, for numbering, for getting the lowest number, always the substituent have a less priority. Substituent has less priority than the double and triple bond. So priority wise, they have less priority compared to double and triple bond. So they would be given the lowest number. They would be given, double and triple bond are given lowest number compared to substituents. Okay. So these are the three main rules, and there are some rules also coming. So as we practice, we will be discussing that. Okay. So please remember these three rules for now. Okay. Coming to question number 1. Okay. So I have CH3, 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 CH2, CH, double bond, CH2. Okay. So first we need to select the longest chain. So select the longest chain in such a way that it includes maximum number of double and triple bond. Here there is only one double bond. So which is the longest chain? So definitely the longest chain is this one, right? If you see that this is the longest chain, right? So this is the longest chain. Now the numbering will start from which part? Do we number from here? 1, 2, 3, 4, 5. We number from here, or we number from here. 1, 2, 3, 4, 5. So our second rule states that numbering is done in such a way that the double and triple bond gets the lowest number. So definitely we will go with 1 for the double bond, right? So we will not use this numbering because this is not giving lowest number to the double bond, right? So what would be the name? So here, these are the two substituents. 2-methyl groups are there as substituents. So what would be the name? The two substituents are at the fourth position. So 4,4-dimethyl pent 1-ene. So if it is 1, if the double bond or triple bond is in the first position, it's okay if you don't mention 1 also, but better to mention so that, mistakes can be avoided. So first we chose the longest chain and the double bond is given the lowest position. So that's why the numbering was from this side. Okay. And then there are 2 methyl groups. So at the fourth position, so 4,4-dimethyl pent 1, right? Coming to the next question. Question number 3. The bond line structure. Now you will be knowing that for bond line structure, each of these ends is representing a carbon atom. Each of these crusts and these troughs, right? So this is one carbon, another carbon, 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 and carbon. Okay. And here, suppose there is bromine. Okay. And here there is a double bond. Right. Now, coming to numbering, we choose the longest chain. This is the longest chain. And the numbering, if we do the numbering from here, 1, 2, 3, 4, 5, 6. Okay, if we do the numbering from the other side, 1, 2, 3, 4, 5, 6. Which one do you think is correct? The numbering should be done in such a way that the double bond is getting the lowest number. So definitely the green numbering is wrong because it is giving number 5 to the double bond. The blue numbering is giving you number 2 to the double bond, right? So we will not use the green one, we will use the blue one. Okay. So here, the substituent is at the fourth position, the 4-bromo hex. At the second position, there is the double bond, so hex 2-ene. Okay. So whenever there is a double bond, we use ene. Okay. So whenever there's a double bond, we use ene. Okay. Now coming to the third question. Okay. So this is one carbon atom. This is another carbon, 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 carbon. Okay. So if I number it from here, suppose 1, 2, 3, 4, 5. In this, there's no substituent, as you can see. The same thing, I can number it in another way. Double bond here, it's a double bond here. I can number the same thing with 1, 2, 3, 4, 5. Both the ways I can number, but in the first one, the double bonds are getting the number 1 and 3. And in the second one, the double bonds are getting the number 2 and 4. Right? So which one would you use? Definitely you will use the rule of first point of, you will use the rule. So you will use the rule first point of difference. This was explained in the previous video. That means you compare the position. This is first position, this is second position. This itself wins. So this position wins. So they will not use this. You will use this. Okay, so what is this rule? First point of difference. Okay. So what would be the name? Word root first. There's no substituent. So we start with word root, pent. And which all positions the double bond is there? 1, 3, diene. Diene because there are how many double bonds? 2 double bonds. Okay. So whenever there's a double bond, we use ene. If there are 2 double bonds, diene. If there are 3 double bonds, 3 triene, and so on. Okay. Now, moving on further. So I'm rubbing it. I hope you understood till here. Okay. Coming to the next question. Carbon, carbon. Okay. Filling it with hydrogen. 1 valency satisfied, 3 more required. Here all the 4 valencies are satisfied. Here all the 4 valencies are satisfied. Here 2 valencies satisfied, 2 more needed. 3 valencies satisfied, 1 more needed. 3 valencies satisfied, 1 more needed. 2 valencies satisfied, 2 more needed. 1 valency satisfied, 3 more needed. Okay. Now, here there's a double bond, here there's a triple bond. Now, whenever there's double and triple bond, both have the same priority. Both have the same priority. So whichever is getting lesser number, you can number them first. Okay. So it's not that double bond is important or triple bond is important. No, both have the same priority. Okay. So here, we number it. Okay. So suppose I'm numbering it from here 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I'm numbering it this way. Okay. Here, the positions of the double and triple bonds are second position and fifth position. Okay. And if I number it the other way around, 1, 2, 3, 4, 5, 6, 7, 8. Okay, here the positions of the double and triple bond are 3 and 6. So students, these are the positions. When I did the numbering first, the numbers of the double and triple bond are 2 and 5. And when I did the numbering from the other side, it was 3 and 6. And again, we will look at the first point of difference. The first point of difference, if you check, this is 2 and this is 3. So definitely we'll go with the first point of difference. So we will be using 2 and 5. Okay, so we will not be using 3 and 5. We will use the rule of first point of difference, which is a very important rule. Okay, now, and we already discussed that both double and triple bond have equal priority. Okay, both of them have equal priority, same priority. Okay, so it is, there is no substituents. So we will write the root word first, oct. Okay, and there is a double bond. For double bond, we use "-ine". If it's a triple bond, we use "-ine". Okay, and whenever there is double and triple bond, we will use the alphabetical order for writing the name first. So definitely E comes before Y. So oct, 5, "-ine". Okay, irrespective of the position, we will write according to the alphabetical order. Okay, only while writing the name. Okay, so while numbering, both of them have the same priority. And 2, "-ine". Okay, and another small rule. Whenever you come across A, E, I, O, U, Y, suppose over here, E is followed by a Y. Okay, so remember these letters, A, E, I, O, U, Y. If one is followed by the other, we usually cancel that. So oct, 5, N, 2, "-ine". Okay, so this is the name. So both double and triple bond have equal priority. So numbering is done in such a way that they get the lowest number. Okay, so both are equally important. Okay. Now coming to the next question. C, double bond C, 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 double bond, triple bond C. Okay, filling in the hydrogens, 2 valencies are satisfied, 2 more required. 3 valencies are satisfied, 1 more needed. 2 valencies satisfied, 2 more needed. 4 valencies are satisfied. Here 3 valencies are satisfied, 1 more needed. Okay, coming to the numbering. If I number it like this, 1, 1, 2, 3, 4, 5. Here, both double and triple bond are equally important. So 1 and 4 are the positions. Same thing if I number from this side. 1, 2, 3, 4, 5. Here also, the multiple bonds are getting 1 and 4 position. So we cannot go according to the first point of difference rule. So there is a tie between both of them. Okay. So whenever there's a tie, see, tie means they have both got the same numbers. I mean, the numbering is the same from both the sides, right? So in this case, who is given more importance? So whenever there's a tie, it is considered as a special case. Okay, where in this type of a condition, double bond is given more priority. Only whenever there's a tie, okay? Whenever there is a tie. Not in the previous one. Only whenever there is a tie. In case of tie, that means same number from either side. You can see here, the numbers are the same. We cannot use first point of difference. The numbers are same from both the side. In this case, double bond is given importance only in this type of a case. Okay, so we will be using this numbering starting from this side, the blue numbering. Okay, why? Because this is a special case. The numbering is same from either side. So what is our name here? So please remember, student, this is a tie. This is a special case. Please remember this only in case of a tie. Okay, otherwise both double and triple bond have equal priority. Both are equally important. So the name is pent 1 in 4th ein. Fourth position, the triple bond is there, and because E is followed by Y, we usually don't write this E, we just write N for ein. Okay, so treat this as a special case whenever there is a tie, same numbering from either side. Okay, so suppose if you have 1, 2, 3, 6, 7. Okay, writing the hydrogens, filling in the hydrogens. 3 are satisfied, 1 more needed, 2 are satisfied, 2 more needed, 3 are satisfied, 2 more needed. This is okay. Now in this case, I can number it from here 1, 2, 3, 4, 5, 6, 7, right? And what are the positions? 2 and 6. I can also number it from the other side 1, 2, 3, 4, 5, 6, 7. 7. Okay, now what are the positions? 1 and 6. Which one will you choose? Sorry, 1 and 5. 1 and 5. Okay, 1 and 5. Okay, now which one will you choose? Here, there is no tie. There is no tie here. The numbering is not same from either side. It is different. So you will go with first point of difference. Here both are equally important. So please remember the special case. Okay, please remember the special case here. In this case, only whenever there is a tie. But in this case, there is no tie going on. Here, the numbering is different and you will go with first point of difference. So definitely first point of difference. This is number 2, this is number 1. Definitely you will go with 1 and 5, not with 2 and 6. I hope I am clear, right? So you will go with 1 and 5, will not go with 2 and 6. So I'm removing this numbering, and our name will be, there's no substituent, so go with the root word hept 1 in. It's okay if you don't mention 1, but better to mention 1 in 5 ein. And because E is followed by Y, I'm just removing this E. So hept 1 in 5 ein. Remember, there's no tie over here. Numbering is different from both the sides, and we go with first point difference. I hope I'm clear with this rule. Right. Okay, students, moving on further. Coming to another question. Okay, and this is carbon, 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 carbon. This is carbon. If nothing is mentioned here, this is carbon, and so this is carbon. This is also carbon, 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 carbon. Okay, filling it with hydrogen. 2 valencies are satisfied, 2 more needed. 3 valencies are satisfied, 1 more needed. 2 valencies satisfied, 2 more needed. 3 valencies are satisfied, 1 more needed. 3 valencies satisfied, 1 more needed. 2 valencies satisfied, 2 more needed. 2 valencies satisfied, 2 more needed. Here 2 valencies are satisfied, so 2 more needed. 2 valencies satisfied, 2 more needed. Here there is a double bond. 2 valencies are satisfied, 2 more needed. Okay, now next is the numbering. Okay, so numbering, if I number from here, 1, 2, 3, 4, 5, 6, 7. Yes, so double bonds are getting the first position and the 6th position. There is no other way to number to include all the double bonds. So numbering is done in such a way, take the longest chain that include most of the double bonds. So it's not possible to include all the 3 double bonds. Okay, so I cannot 1, 2, 3, 4, 5, 6. No. So here we are getting only 6 carbons. So the one that we numbered first, we are getting 7 carbons and 2 double bonds included. Okay, so if we number from this side, 1, 2, 3, 4, 5, 6, 7. This is also, by this way also, you're getting the double bonds at the first and the 6th position. So it is symmetric. And in both cases, you're getting the substituent at the 4th position. Now this has become your substituent now. Okay, you cannot include this double bond also in the numbering. Okay, so this group, what is this group called? Now, suppose if I have methane and you remove 1 hydrogen, it is called methyl, right? You have ethane and you remove 1 hydrogen, C2H5, you call it ethyl. right? Now this is not ethane. This is not ethane group, right? Here there are two carbon atoms with double bonds, right? This is the connection. This is the connection. Now this is ethene, from which one hydrogen has been removed, right? So one hydrogen has been removed. So ethenyl group. So this is the ethene group from which one hydrogen has been removed. So this is ethenyl. And because E and Y are near to each other, we will remove this E and we get ethenyl. Ethenyl. Okay, so this is the ethene group, yes. But from here, one hydrogen has been removed. So we write it ethenyl. Okay, so that is the substituent. I hope you understood why we wrote ethenyl. So this substituent is ethene group from which one hydrogen has been removed. Usually ethene is CH2 double bond CH2 and one hydrogen has been removed. So we get this group, and this is ethene group with one hydrogen getting removed, like methyl, ethyl, same way ethenyl group. Okay, so what is the name? We name it as what? 4. At the fourth position, we have the substituent. What is the name of the substituent? 4-ethenyl. How many carbon atoms are there? Root word, hept. There are double bonds at the first and the sixth position. 1,6-diene. 1,6-diene. I hope you understood this, right? So just to explain once again, this is the ethene group. One hydrogen has been removed. We have CH double bond CH2, and from here it is connected to the main group. Okay, so this is ethene, ethenyl, and because E is following Y, E is followed by Y, we remove this E and we write it as ethenyl. Just as we remove hydrogen from the methane, we call it as methyl. Same way. Please take a note of this. I explained it before also, just explaining it again. Okay. Similarly, one more example I would give. CH triple bond CH. This is ethyne group. If I remove one hydrogen, this is the connection is made here, and CH. This here connection made here means it is connected to the main group. Suppose here we call this ethenyl, and because E is followed by Y, we remove this E and we call it ethenyl. I hope you got this. Please take a note of this. Okay. Suppose I give an example. Suppose we take this example. Okay. And so here there's a triple bond. And here there's a double bond. Here also there's a double bond. And all these dots are the carbon atoms. So let's write down the carbon atom. This is one carbon, 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 carbon. This is one carbon, carbon, carbon. All these are carbon atoms. So we have to number it in such a way that we get the longest chain as well as we include the maximum number of double and triple bonds, and also we have to number it in such a way that the double and triple bond gets the lowest number. Okay. Suppose if we number it from here, 1, 2, 3, 4, 5. If we number it 6, 7, we are getting only 7 carbon atoms. But if we go this side, 6, 7, 8, 9. So it is giving you longer chain. And if we number this way, we are including 2 double bonds here. Okay. Now we can also number it. And here, if we number 1, so let me number it, draw it again so that, it's clear for you to understand. Let me draw it here. Okay. Over here it is like this, and so here there's a double bond, here there's a double bond, here there's a triple bond. Okay, so if we number it this time, if we number from here 1, 2, 3, 4, 5, 6, 7, it is getting only 7 carbon atom. So we will not go this way. Instead, it's a triple bond. Okay. Instead, we will go 5, 6, 7, 8, 9. Okay. This is also giving you 9 carbon atom and it has included the 2 double bonds. Okay, no problem, because double and triple bond both have the same priority. Now over here, if you see, the double bonds are in first position and 7th position, right? And in this case, it is in the 2nd position and 8th position. So if you see the first point of difference, this is 1 and this is 2. Clearly, you will go with this this numbering, okay? Because you are checking the first point of difference. This is 1 and this is 2 clearly. Okay, so we will not use this numbering, we'll use this number. Okay, I hope I'm clear over here. Now, if you use this numbering, okay, now you can see this is CH2, this is CH3, okay, and this is CH, this is C. Okay, now over here, this is your substituent, C2H5, ethyl group. This is one of your substituent. Now, this is your next substituent. Now, this is just a substituent now. Now, this is no longer very important because this carries a triple bond, doesn't make it important. This has become just a substituent now. So I'm rubbing off this part because we don't need this part. Now, we selected our numbering, so we don't need this. So what I'm trying to say is, although this has a triple bond, it is just a substituent now, just like our ethyl group. Okay, and we know how to name this substituent. See, I took this example. From ethine, 1 hydrogen is removed and you get ethanyl. Okay, so we know how to name this substituent also. So now, at which position is our at which position are our both substituents? We have at the fourth position, we have our ethyl group. This is our ethyl group. You know this, ethyl group. And at the 5th position, we have our ethanyl group. So you know how to name it. I have just shown it just a moment ago here. Okay. Now, here, just because ethanol is having a triple bond doesn't make it important. It is both of them just are substituents now. Both have equal importance now. And you are going to write the name according to the alphabetical order. Okay, so E is same, TT same, HH same, ethanol here, N is there. So L comes first, then N comes, right? So we will write 4 ethyl, 5 ethanol, 9 carbon atom root word non, 1, 7, the double bonds are at the first and the seventh position, 1, 7 diene. I hope I'm clear and you understood why, even though this has a triple bond, it is just a substituent and we follow the alphabetical order while naming. Okay. Now, I hope it is clear. Now let's move on to some cyclic substances. I know we have not done cyclic substances in detail. We will be doing a little now and then I'll be discussing the lot of cyclic substances in a new video. Okay, for now, just follow the rules. Okay. So this is, I hope you made a note of this. Okay. Now, coming to cycloalkene. Cycloalkene means these are closed chain alkene. Okay. For example, if I write like this CH, CH2, CH2, CH, double bond here. Okay. So this is a closed chain alkene. There's an alkene group here. There's a double bond here and it's closed chain and I can represent it like this. Okay. So this is called as cyclo groups. That means it is closed chain alkene. What is an open chain alkene? If I write like this. This is closed or open chain. This is open chain. Right? It's not closed like this. This is a closed chain. This is open chain. Okay. So such closed chain alkenes are called as cyclic alkenes. Okay. Now, let's go with the name for this over here. Definitely we'll start the numbering from the double bond first. 1. Okay. Now, 2, 3, 4. So the keyword that you would write is cyclo. 4 carbon atom means bute. If it's a closed chain alkene, you will use the word cyclo. Cyclo, bute, 1-ene. You will not write bute 1-ene. Bute 1-ene means it is open chain. What tells you that it's cyclic? Cyclo, bute 1-ene. Okay. Similarly, if I have something like this is one carbon, this is another carbon, this is another carbon. So 1, 2, 3. Is this a cyclic substance? Yes. So we name it what? Cyclo. 3 carbon atoms are there. So the root word is prop 1-ene. The double bond is at the first position. Okay. So over here, the next example, if I'm giving bromine, this is carbon, this is carbon. Okay. Now, here, there is a substituent here, bromo, and there's a double bond. Who is given more importance? Always we have, before we discuss that, always a double and triple bond have more priority than the substituents. So the numbering will start from here, 1, 2, 3. Okay. And usually, as far as possible, giving the first and second position to the double and triple bond. Okay. So this is substituent first, 3-bromo, then cyclo, prop, 1-ene. Okay. So the double and triple bond are very important than substituents. Suppose you have this kind of a compound. Okay, this is also a closed chain, you can see here. Now there are 2 double bonds. Okay, suppose you have to number it. Okay, so if you have to number, you will give this number 1. Okay, second position, definitely here, third, 4, 5, and 6. Okay, so here, whenever there's a double bond here, okay, so if you are giving the first position here, the second position will come to the next edge of the double bond. What I mean to say is that here, this compound, if you're giving number 1 here, you cannot go to number 2 like this. If the one edge of the double bond you're giving number 1, you have to give the next edge number 2. You cannot go this way. You have to follow one direction like this. Okay, so what is the name of this compound? So the double bonds are getting first and the fourth position, right? So this is cyclic substance, cyclo, hex, 1,4-diene. Okay, so we are following the same rule here. Substituents are named first. Okay, and if a cyclic substance is there, we use the word cyclo. Remember, for the prefix. So I just remind you once again. Okay, remember, for the prefix, one was a secondary prefix that was for substituent, and one was for primary prefix that was used for cyclo if it is present. Here there is cyclo, so I'm just mentioning it again. Then you have the word root. Then you have the suffix. So first, if there's a substituent, you write the name of the substituent and the position. If it's cyclo, you mention cyclo and then the word root. So here there is no substituent, so I started with primary prefix, that is cyclo. Then the word root is hex. Then suffix is how many double or triple bond is there. Okay, I hope you understood this. So I'm just keeping it here. Then coming to the next one. Okay. Now here, in this case, suppose I number it from here, 1, 2, 3, 4, 5, and 6. The double bonds are getting the positions 1 and 3. Right? Is there any other way of numbering? I can also number it from here. 1, 2, 3, 4, 5, 6. I can number it from there also. And what are the positions I'm getting in that case? 1 and 2. Sorry, 1 and 3. 1 and 3. See the black one. 1 and 3. In either way, both are getting numbers 1 and 3 for the double bond. So following this order, there is no substituent. So I start with primary prefix, which is cyclo. So cyclo, root word is what? Hex. What positions are the double bonds? 1, 3, diene. Right? Coming to the next example. So this is what you have to remember. Now, coming to the next example. Yeah, there's a substituent now. Okay, I'll draw it again so that I can number it in a different way and then compare which numbering is correct. So there's double bond, there's a bromine here. So if there is a substituent and a double bond and a substituent, definitely double bond is getting more priority. So definitely the double bond will get number 1. So, and I mentioned that if one end of the double bond is getting number 1, the other end has to get number 2. That means if one end is getting n, the other end will be, the next end will be n plus 1. So definitely I cannot write here 2. No, I have to go to the next edge of the double bond. Then third position, fourth position. Yes, I can also number it in the, I can give this number 1. So I cannot write here number 2 just because there's a substituent here. No. So if there is a substituent here also, I cannot number this 2. I have to go to the next edge of the double bond, that is 2. If you're giving this n, this will be n plus 1. Okay, so here, definitely it will be 3. Here it will be 4. Okay, now, which is a better number here? So definitely here, the double bond is in the first position, substituent is third position. Here the double bond is in the first position, substituent is in the fourth position. Definitely you will not go with this, you will go with this. First point of difference also supports this. So first, what is the name that we write? We write down the substituent, then cyclo. If it's a cyclo substance, write down cyclo, then word root, right? So substituent is bromo at the third position. Bromo. Cyclo. Root word is but 1-ene. I hope I am clear. Right? Moving on further. Okay. Moving on further. Suppose I have another cyclic substance. Okay, I have 2 substituents and I have a double bond here. Okay, I redraw it again so that I can do the numbering in different ways and compare which is the best numbering. Okay, now suppose double bond and the substituent, definitely double bond is given preference. So if I give this number one edge, if I giving number 1, the other edge should get number 2, right? 3 and 4. Okay. I can also number it this way, 1, 2. So I cannot number this 1 and go to the next number. That's just because there's a substituent. No. If one edge is given number 1, the other edge should be 2. If one edge is given n, the other edge should be n plus 1. Okay. The third one is 3. This is 4. Now which one here? So here there's a double bond, there's a substituent. Double bond is getting number 1, substituents are getting 2 and 3. Here the double bond is getting number 1 and the substituents are getting 1 and 4. Check the first point of difference. Here both are same. Okay, that's fine, and it has been given least number, so fine. Here, first point of difference, this is 2 and this is 1. Sorry, this is 2 and this is 1. Which one would you prefer? Definitely this one. Here, the first point of difference you would follow. First point of difference. End of the story. You don't have to choose this. You will go with this. Okay, so now writing the name. First, writing the name of the substituent with the position. 1,4-dichloro. Then primary prefix cyclo. Root word but. 1-ene. Okay, I hope you understood why we are going with this, because see the root point, the first point of difference, right? So we will not be using this. Okay, similarly, if I am giving you another question over here, chlorine, bromine. Okay, I'll redraw it again so that I could check the best numbering. Chlorine, bromine. Okay, over here, this is a double bond, so I'll give number 1 here. I cannot go and write 2 over here, because if I'm giving one end of the double bond number 1, the other end will get number 2. So this is 3, this is 4, this is 5, and this is 6. And I can also number it this way: 1, 2, 3, 4, 5, 6. So here the double bond and the substituent. Double bond is given number 1, substituent is 1 and 6 position. Double bond is 1, substituent is 2 and 3rd position. So now double bond is fine, but looking at the substituents. First position, 2 position, second position here. Which one would you follow? The first point of difference, definitely. So you will go with this. You will not go with this, because here the first point of difference is 1 and here it is 2. So definitely you will not choose this. You will choose this. Okay. So you're not using this numbering because of the first point of difference. Now at the first position, you have chloro. At the 6th position, you have bromo. They are both substituents. Which one would you write first? So if there are 2 substituents, you will follow the alphabetical order irrespective of the position. So B comes first. So 6 bromo, 1 chloro. Then what? primary prefix, which is cyclo, because it's a cyclo substance. So cyclo, what is the root word? Root word is hex. And then the suffix, that means double or triple bond. In which position? First position. 1 in. This is how you name it. Okay. I hope I'm clear. Right. Here you will not look at the sum. You will go to the first point of reference. Okay. Coming to the next example. Chlorine, iodine, bromine. Okay. I'll redraw it again so that I can number it in another way and check which is the best numbering I can do. Iodine, chlorine, bromine. Okay. Now, if I number it, definitely double bond is going to get first position, 1. I cannot go over here because if I'm giving one part of double bond 1, the other end will get number 2. Okay. Third, 4. And there is another way of numbering, 1, 2, 3, 4. So here the double bond is in the first position. Substituents are at the third position and fourth position. Double bond at the first position. Substituents at the third position there are 2 substituents, 3, 3, 4. Here the substituents are at 3, 4, 4. Okay, so here 3, 3, 4, and over here 3, 4, 4. So first point of difference is the same. Second, over here check. This is 3, this is 4. So end of the story, you will not use this, you will use this. Okay, because the first point of difference, 3 is lesser. So that is why you will not use this, you will use this. Okay, so over here, first the substituents. We will follow the alphabetical order because there are 3 substituents there. 4 bromo, 3 chloro, 3 iodo. See, I'm following the alphabetical order because there are 3 substituents. 3 iodo. Then we use the primary suffix cyclo, root word bute. First position, the double bond, bute 1. Okay. Now, moving on further. If I have this kind of a structure, here there is CH2, CH3. Okay. Now, here, this is the substituent, right? So this is the substituent. This is the substituent ethyl group C2H5. This is the substituent. The numbering, definitely if you number from here, you will get 1, 2, 3, 4, 5, 6, right? You will not definitely number from here 1. If you number here 1, it will get second position, 3, 4, 5, 6. So which is better? Double bond is at the first position, substituent at the third position, double bond at the first position, substituent at the sixth position. Definitely you'll go with this, right? So I'm removing this. 1 and 3 is better comparatively. Now, how will you name it? Substituent first. 3-ethyl, then primary prefix cyclo, root word hex, 1-ene. You can just write hexene also, no problem, but just better to mention the position. Now, in case you get a structure like this, okay, CH double bond CH2. Okay, there is a ring, there's a straight line structure. Now, which one will be your substituent? Which one will be your root word? Now, in such a condition, among ring or straight chain, this is the straight chain, and this is the ring, you know that. Among ring and straight chain, if you have to choose which is the straight chain and which is the substituent and which one is the root word, there is a small rule. Root word will be for that who has functional group or priority. I'm writing the priority order. Priority order. If the root word has a functional group, if the functional group is there, that will become the root word. Or if double or triple bonds are there, that can also become the root word. Or now number of carbon atom more carbon atom. More carbon atom. So, how will you choose the root word if you have a confusion among ring and straight chain? If there's a ring and a straight chain together like this, how will you choose the root word? If anyone has functional group, that can become the root word. If functional group is not there, check for double and triple bond. If they have double and triple bond, end of the story, that will be the root word. If they don't have double or triple bond, go with carbon atom. If more carbon atom, that will become the root word. Okay, over here, there's no functional group, but there's a double and triple double bond. So definitely this is our root word, and this will become our substituent. Okay, and this will become our main chain. Why? Because there's no functional group, but there's a double and triple bond. If functional group is not there, go with the next one. Go with the next priority, double bond. Okay, double or triple bond. Here there's a double bond. So I'll redraw it again. So this is our main chain, CH double bond CH2. Why? Because there's a double bond. Okay. So this will become our substituent. Okay. If suppose both of them have double bond, then go with number of carbon atom. Okay. So what is the name of this one? 1, So this is our substituent, and this substituent name is cyclohexane, right? And from this carbon, one hydrogen has been removed. And if the hydrogen is removed, one hydrogen has been removed, so it will become cyclohexane hexanyl. Okay, like for example, methane. From methane, when one hydrogen is removed, it becomes methyl, right? Same way, cyclohexanyl, and because E and Y are coming together, we remove this E. So we have 1, 2, 1 cyclohexanyl. This 2 carbon atom means ethene. Eth, 1 ene. Double bond and substituent are at the same position. I hope I am clear. Now, coming to the next example. So I hope I'm clear. So if there is a ring as well as a straight chain, you will determine the root word. If the functional group is there, that will become the root word. If functional group is not there, check for double bond. If double bond is there in both of them, then check for the number of carbon atom where it is more. Okay, so I'll keep this. Okay, now giving you another example. Okay. Now, carbon, double bond carbon, single bond carbon. So CH2, 1, 2, 3, 4. 4 has been satisfied. Here, 3 plus 1, 4. Now, check. Here there is a straight chain. Here there is a ring. So first check. Functional group. No functional group is there. Check for double and triple bond. Here there's a double bond. So definitely this has become what our root word. And this has become our substituent. Okay. On the basis of this priority list. Okay. So let's do the numbering first now. This is our root word. So double bond is given smaller number 1, 2, 3. So what is our substituent? It is propane. From this carbon, one hydrogen is removed and then it is attached to the main chain. So one hydrogen. So propane aisle. So E and Y are coming near to each other. So remove that E. So prefix we write first, primary prefix 2 cyclo propi 2 cyclo propenyl. What is the root word here? 1, 2, 3 carbon atoms. So prop. The double bond is at the first position. Prop 1 in. Okay. Another example. Okay. Now, over here, this is the straight chain. This is the ring. Which one will become the root word? Go for functional group, there's no functional group. Go for double bond or triple bond. Here there's a double bond. So this will become our root word. And this will become our substituent. Okay, so go with the priority list. Okay, so this will become our substituent. Okay, now. So the root word will be number 1, 2, 3. So the substituent is at the third position, right? The root word, because the double bond. See the priority list. If functional group is not there, then go with double bond or triple bond. So third position, we have how many carbon? 1, 2, 3, 4. So at the third position, butane, one hydrogen has, so here the one hydrogen has been removed from here. So butane, if one hydrogen is removed, it is called butyl. Okay, so third position, butyl group is there. This is the butyl. 1, 2, 3, 4. Butyl, cyclo, prop, 1, ene. The double bond at the first position. Cyclo, prop, 1, ene. Okay. I hope you got it. Okay. Now moving on further. Moving on further. If I write this kind of a structure, okay. Okay. So this is carbon, 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 and carbon. Here 2 valencies are satisfied, 2 more required, 3 satisfied, 1 more required, 4 of them satisfied. Here 3 satisfied, 1 more needed. This is 2 satisfied, 2 more needed. Okay. So start with the numbering. If I start numbering 1, 2, 3, 4, and 5. Okay, so this is one way of numbering. And if I number from the other end, 1, 2, 3, 4, 5. So in both of them, I'm getting 5 long carbon chain, and from either side, in the first case, the double bond is in the first position and in the fourth position. And in the second case, it is in the first position and fourth position. So both ways it is same. So I'm just taking, so both ways it's same. So I'm just taking this way of numbering. Okay. Now this is our main chain. Okay. And that means this is our substituent, right? Now, this substituent in which there is a main chain and there is a connection directly from the main chain with a double bond. What is it called? Okay, so here with the double bond, the substituent is directly connected by double bond to the main chain. In such a case, we have not discussed this before. This is called as alkylidene. So, when a substituent is connected directly by double bond directly with the main chain, it is called as alkylidene. Okay, in this case, it is called, there is only one carbon atom. It is called as methyl group methylidene. Okay, so here the substituent is at the third position. And what is the substituent called? Methylidene. 3-methylidene. Pent. And this is the root word, pent. And at what position are the double bond? 1,5-diene. Okay. Similarly, if I have the structure, okay. Okay. Now, if I number it, I can number from here 1, 2, 3, 4, 5, 6, 7, 8. Longest chain with including both the triple bond. So from here, I'm getting the largest chain. 7, 8, sorry, 9. Similarly, if I start from here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Either way, I'm getting the triple bond, 2 triple bond, and I'm getting the longest chain. So I can use this numbering. And also here you can observe that this is our substituent now. Here to the main chain, there is a connection with the double bond. So this is CH3 and this is CH. So here there are 2 carbon atoms, right? So I told you whenever there is a connection directly to the main chain with the double bond, it is called alkylidene. In this case, what is it? What is the substituent? Ethylidene, because there are 2 double bond. Ethylidene. The substituent is ethylidene because this ethyl group is connected directly to the main chain with the double bond. Okay, and which position is the substituent? 5. Ethylidene. And what is the root chain? Non. What positions are the triple bond? 1, 8, diene. Diene, not diene, diene, because this is a triple bond. Okay. Similarly, if to the main chain, if I have 3 carbon atoms connected, CH, CH2, CH3, what is this called? This is called as propylidene. Okay, so please remember this special case, propylidene. Okay, so there should be a double bond connecting this substituent to the main chain. Okay, and in case of alkylidene or in case of methylidene, sometimes it is also in some books also referred to as, some books only for which one? Only for methylidene. Some books refer it as methylene also. So both the naming is correct. In some books, you find it as methylene, in some books, methylidine. But for ethylidine and propylidine, this is the name that you find. Okay, I hope I'm clear here. Okay. Now, let's do some questions now. Some more questions. Yes, we've been doing a lot of questions. Let's practice some more. Suppose I have this kind of a structure. Okay, there's a double bond here. Okay, suppose you asked to name this. So there are two rings. Among the two rings, which one will you make it as the word root? So first we check the functional group. Functional group. Functional group. If functional group is not there, we check for double or triple bond. If both have double and triple bond, then we check for the number of carbon atom. More number of carbon atom, that will be the word. In this case, we don't have functional group, but we have a double bond here. So this is our word root, and this is our substituent. Okay, and let's go for numbering. Numbering, the double bond will get the smaller number 1. I cannot put 2 here because I told you if one end of the double bond is getting 1, the other end will go 2. 2, 3, 4, and 5. Okay. So at the 5th position, we have the substituent. Okay. So what is the name of the substituent? Substituent is at the 5th position. At the 5th position, it is a cyclo compound, yes, and cyclopropyl, because here there is a carbon. One hydrogen has been removed, and then this connection is brought about. So one carbon is removed, one hydrogen is removed. It is called as, it's a prop group, yes. It's a cyclopropane group. Okay, because it's 3 carbon atom. But from here, from this carbon, in order to bring this connection, one hydrogen has been removed. So whenever you remove one hydrogen, it is called as propyl or yl group. From methane, if one hydrogen is removed, methyl. If from ethane, one hydrogen is removed, ethyl. From propane, one hydrogen is removed, it is propyl. And then substituent we have named. Now coming to the root word, cyclopent. At what positions are the double bond? 1, 3, di-ene. Okay, why cyclopropyl? Because here there should have been a hydrogen, but that hydrogen has removed to bring about this connection. Okay, so that is why propyl. Okay. Moving on further. I'm sure you will be able to do this on your own. Here, there are 2 rings. Okay, this ring, I didn't make it properly. Okay. Now, there are 2 rings. Which one will you make it the root word and which one will you make it the substituent? So first, you check the functional group. Functional group is not there. Are there double and triple bond? Yes, there's a double bond here. So this is our root word and this is our substituent. Okay, so numbering the 1, 2, 3, because double bond always lower number. And at the third position, what do we have? We have a, what is the name of the substituent? Cyclo. This is a pentane group. From this carbon, one hydrogen is removed to bring about this connection. So cyclopentyl group. At what position is the cyclopentyl group? Third position, 3-cyclopentyl. So this is our substituent. Our root word is cyclo, prop. At what position is the double bond? 1-ene. Okay, I hope I'm clear here. Okay, now the same question. In the same question, I have a double bond here. Okay, now both of them now both the rings have a double bond. So first we check for what? We will check for the functional group. If it is not there, then we go for double bond. In both rings, there are double bond. Then if both rings have double bond, what do we check? We check the number of carbon atom. So where is the number of carbon atom more? Obviously, this is our word root, and this is our substituent, because both have a double bond. So we are checking for more number of carbon atom. Okay, so we are checking for more number of carbon atom because both of them have double bond. Okay, so I hope I'm clear here. So over here, we are numbering it. So we number from here 1, 2, 3, 4, 5. Okay, so if we number from here, it will be 1, 2, 3, 4, 5. So in both the cases, the double bond is getting the smaller number 1, and in both the cases, the substituent is at 4. So anyway, we can number, no problem. Now, so the substituent is at the 4th position. Okay. Now the substituent is also a cyclo group. So this also we have to number, because if we just say cyclopropyl group, okay, so we are not able to specify this double bond. So in order to specify the double bond, we have to number this also. 1, 2, 3. Okay, so why I put this number 1? Because here the carbon atom that is connecting to the main chain is always given number 1. Okay, so carbon that connects, this I'm talking about the substituent. If you are in this situation, if you have to number the substituent, carbon that connects to main chain is given position 1. First position. So I have numbered this 1, 2, and 3. You can go 1, 2, and 3. So no problem. Right. So at the 4th position, we have the substituent. So cyclo. So definitely this is a cyclo substance, prop. And propyl group, yes, but we have to specify the ene group also, right? At what position is the ene? 2, ene, yl. So it's like propenyl group. So propene also is there. Propene for the double bond, and yl because one hydrogen has been removed from this connecting carbon, right? So here E propene I. So here I'm removing this E because E and Y are coming together. So E N Y L. So there is a ene is for the double bond. Yl is because one hydrogen is removed from this connecting carbon. There should have been a hydrogen here, but this hydrogen is removed because it is using that bond to connect it to the main chain. Okay, that is why yl group. Okay, it should have been, if I'm removing one hydrogen, it is becoming propyl group. So same thing I've written propyl, and because there's an ene group there, there's a double bond, ene also I'm including. So propene yl group, propene yl group. Okay, propene yl group. This is our substituent. Coming to the main chain, cyclo. This is our main chain, main word root, cyclo, pent. At what position is the double bond here? Pent 1E. Okay. So these are called as, this is called as complex substituent. Okay. So these are called as complex substituents. This is called as complex substituent. Why complex substituent? Because you have to number it in order to specify the double bond or a triple bond if it is there. Okay, so such substituents are called as complex substituents. So the whole video on complex substituent, I will make it as a separate video. Okay, so I'm this just as an example, I just included. Okay, so that I introduced that complex substituent there. Okay, I hope the numbering and the rules for naming or nomenclature of alkene and alkyne is you understood, and please practice the questions. Okay, I try to include as far as possible most of the examples. Okay, some more examples I will be practicing when I do the past paper questions. Okay, students, that's all for today. Have a great day.